By the end of this module, you will have a basic understanding on car parking application, how it works traditionally, and Danfoss solution. The key benefits of using a VLT HVAC drive in car parking systems. Let me begin by explaining a car park system to you. Fully enclosed underground car parks require mechanical exhaust ventilation to extract carbon monoxide built up at peak traffic periods. Carbon monoxide becomes potentially lethal when undiluted with fresh air, and needs to be monitored in order to have acceptable concentration at all times. The concentration of carbon monoxide in car parks reaches a dangerous level only during peak traffic periods. However, conventional ventilation fans operate all day at full flow, resulting in the wastage of energy. Carbon monoxide sensors are available on the market. They monitor carbon monoxide concentrations and can be used with VLT HVAC drive in order to maintain optimum control with minimum energy consumption. Other concerns related to car park include oxides from nitrogen, smoke from diesel engine, and other contaminants, such as gasoline fumes. Axial fans are usually installed in the car park because they are ceiling mounted and require less space than centrifugal fans. Exhaust grills and ductwork is distributed throughout the parking area to pick up car fumes and exhaust them to the outside, usually through the roof, in order to minimize concentration of fumes. We shall look at a traditional car park solution. The conventional ventilation design consists of an on-off control and sometimes involves two-speed motors. The simplest method of car park ventilation is to start and stop fans when the structure is open. Sometimes, this is in 24-hour operation, including night operation, at very light vehicle traffic. The fans are sized to handle peak traffic load. Take a look at the illustration. It shows the density of traffic. You can see that, when the traffic is lighter, and carbon monoxide levels are acceptable, the fans are either turned off or operate at the lower speed setting. You can also see from the graph that, with less number of cars, the flow is less. Similarly, when the traffic is heavier, and carbon monoxide levels are high, the fans are operated at higher speed setting. The graph illustrates that, as the number of cars increases, the flow increases. We just saw the working of a traditional car parking system, and found that it has the disadvantage of being limited to on-off control, or two-speed settings. Now, let us see the Danfoss solution, applied to car park systems. When controlled by a VLT HVAC drive, the fans have the ability to run at speeds, depending on the traffic load, and are not limited to maximum speed settings. The carbon monoxide sensor is connected to the VLT HVAC drive, which in turn monitors the concentration of carbon monoxide. In traditional solution, the decision to run the fan at high or low speed is often made by employees who are in charge of operating the car park. Automating the fan control with VLT HVAC drive helps us to eliminate the potential danger of human error, where the fans may be unknowingly operated at low speeds during peak traffic times or wasting a large amount of energy if left operating unnecessarily at full speed for long periods. Even compared to two-speed fan systems, large energy savings can be made by controlling the fan with the help of the VLT HVAC drive. Take a look at the illustration. It shows the various levels of speed flow in accordance with the number of cars. As the number of cars increases, the carbon monoxide concentration increases, thus resulting in increase in speed, and if the carbon monoxide concentration decreases, the fan speed decreases. Thus various levels of speeds are achieved according to the number of cars parked. The carbon monoxide concentration is monitored by the carbon monoxide sensor, which is connected to the VLT-HVAC drive. Now, click on the plus or minus button to view the increase or decrease in the number of cars and their corresponding change in speed and flow. Or else, click on the play button to continue. We just saw that Danfoss VLT-HVAC drive facilitates energy saving in the application. To calculate the potential savings over time, the actual load versus time profile must be known. The load profile indicates the flow required by the system in order to satisfy its load during a typical day, month, year, or the time period under study. Take a look at the graph indicating the energy consumption over time. It shows the typical load profile of a HVAC system. You can notice that, in a traditional car park system, there are two types of control, like on-off, and two-speed control. In on-off control, the energy consumption is full during on condition, and zero during off condition. In two-speed control, the energy is consumed according to the number of cars parked. When more cars are parked, the energy consumption is high, and vice versa. In Danfoss solution using the VLT-HVAC drive, this profile will vary, depending on the amount of traffic in the car park. Before ending this module, let me give you a brief summary of what we learned. In traditional method of car parking, the major disadvantage is that the system is limited to on-off control or two-speed settings. But we saw that, in Danfoss solution, we can achieve various number of speeds, according to the number of cars parked. A study of the energy savings shows that Danfoss solution, where a VLT-HVAC drive is used, provides considerable energy savings when compared to the traditional methods. With this, we come to the end of this module, describing the car parking system.